Welcome and thank you everyone for joining us today for Bluelock's webinar, Architecting Recovery as a Service, DR Stories from the Trenches. I'm Alicia Gaba and I'll be your moderator for this session. Your speakers today are Bluelock CTO Pat O'Day and Solutions Director Ben Miller. We encourage you to tweet about the session using the hashtag BLRAS. And this webinar will last no more than 30 minutes, and please feel free to submit your questions throughout the session using the chat function in the WebEx panel. And now I will go ahead and hand it off to Pat to get started.
Great, thanks Alicia. Hey everybody, how you're doing well. Ben and I are going to walk through three different RAS architectures that we actually have in production today, and we're going to use each one to try and draw out the contrast around some specific design challenges or inefficiencies that we've encountered that crop up when you try to really replicate to the cloud to do disaster recovery as opposed to, maybe using disk-based or tape-based backups or, other more traditional methods. So we're going to go over a really high-level architecture overview, and then we're going to deep dive into three different scenarios. One's going to illustrate to-cloud recovery, which means you're replicating from your vSphere environment into the cloud, and the cloud is serving as your backup site. Scenario two is in-cloud recovery, where you might have a production application already sitting in the cloud, in a virtual data center in the vCloud, and you're replicating it to a second location. It's also a VMware cloud environment. And then the third scenario is a to-cloud recovery scenario, but we're going to focus on optimization because this particular environment is experiencing a lot of growth after their initial implementation. So they ran into some new challenges that were related specifically to just driving a lot of additional backup to the cloud. Quick thing about Bluelock, if you don't know us or aren't familiar with us, we're infrastructure as a service provider. We host virtual data centers. Virtual data centers are a pool of CPU, memory, storage, and network capacity. We have a very strong VMware focus. We're a certified vCloud data center provider, one of only, I think, 2 or 3 in the U.S. We offer a lot of different delivery models depending on what your needs are. Obviously, production and disaster recovery are 2 different types of workload needs. We also focus a lot on visibility and transparency to hopefully extend the level of control and really, I guess, control and visibility about what you have in your own environment to the cloud as you start to experience more of a hybrid cloud journey. When we talk about virtual data centers, we have 3 models. We have a 5 series, which is production. It's got high availability. It's got options like encrypted storage, things like that. But it's meant really for production applications. We have our 4 series, which is really going to be the star of the show today. That's our recovery as a service virtual data center. So it would be the target for you if you were replicating data into the cloud. And then 2 series is our pay-go, kind of more of a classic cloud environment where you only pay for what you use, and it's really focused around test development, things like that, if you needed 30 machines over the weekend and want to throw them away on Monday. This is an example. If you sort of threw all these together with an emphasis on architecture, what you can see here is we've got multiple locations, Vegas, Indianapolis. You've got 5 series virtual data centers hosting production applications in both sites. This 5125 here is actively being backed up by a 4 series in Vegas, so in case something would happen to Indy, you'd be able to recover in Vegas. But then in this example, you've actually got someone here with their vSphere environment in their own private data center backing up an internal application to a 4 series in Indianapolis. So hopefully that gives you a general sense of, if you put all the Legos together on one slide, that's sort of what it would look like. Figuring all that out can be challenging, and that's one of the things that we put a lot of time and investment in lately. Is we've also launched an advisory services practice. We have professional services and managed services, because we realize that not everybody necessarily can get started with this on day one. It's very new. Some of you would prefer to have this as a service for the entire lifetime of how long you were going to use cloud services. Others need maybe 60 or 90 days worth of a wrap it up on-ramping, and then you can take over and it becomes a new skill set for your in-house staff, and we're basically willing to work with you at whatever level. So anyway, on with the show. So in terms of the first architecture that we're going to walk through, this is a scenario where we have a customer on the East Coast. It's to cloud, so this is their data center replicating from their vCenter environment over here on the East Coast to our data center in Indianapolis. They're using a 4 series virtual data center, and their biggest issue was they are concerned about an event like Hurricane Sandy happening again, which actually did impact them in the past. So with that, I'll let Ben take over. There are 2 real big issues that you have in that scenario, right?
Yeah, in this particular situation, they wanted to be able to port their public IP addresses when they declared. So getting their data over to Bluelock and replicated was just step 1. They didn't want to have to deal with DNS timeouts or other types of challenges of how to get their public end users to their site when it failed over. So you see in the diagram, you're moving their public space to the cloud when they declare. That's great. That's a fantastic way to do it. We've helped them with that, but they brought up the question of, all right, well, we would like to test. We encourage testing. You know, as a matter of fact, Bluelock's product includes testing. So how do we test without swinging their production IP address? So the way that we approach this, our team worked with theirs to kind of architect a testing model and a production model. The product that we use to do replication has built-in declaration and testing automation to allow the virtual machines, the vApps that are being sent to the cloud, to be brought up on either a test network or a production network. And that allows this sandbox-style testing onto a test network. And so, for example, if you look at this diagram, you can see over here on the right-hand side that there is a testing virtual firewall and testing network with IP space assigned to it. So when the client goes and performs a sandbox test, the virtual machines power up behind all of them on the test network. The diagram's a little misleading. Everything would be on the test network during that test. They'd be able to validate and QA that the application's working properly. At the same time, over to the right, it's a little grayed out, but you see the production failover firewall is here, and it would have its production IP space. It's being kind of protected or hidden to protect the innocent there. That would allow them to, in the case of an actual declaration, when their IP is brought over and advertised at Bluelock, be able to have the same machines at the bottom connected to the production network in the exact same way they were in the testing. It just so happens that when they leave the firewall and go out to the real world, their NAPs are different now, and they've been able to test this in the past.
So really, you have 3 options, right? You could actually use DNS to switch from your existing IP addresses to a brand new set of IP addresses. Through BGP, we can actually, if you have that capability, we can actually map your existing IP addresses and reroute them to a new location. Or you could actually declare into a sandbox and completely mask yourself off from the universe and basically do a functional test without any public-facing
Absolutely.
IP, right? Okay.
Absolutely. And with vCloud Director, you have access to the environment here at Bluelock during the test, so your last scenario fits very well.
Yeah, so even though the world can't necessarily access your application and get confused, you can, right, to make sure it worked. Cool. Okay. So the next scenario is in cloud, which means you have a production application at a Bluelock data center, and for some reason, heaven forbid, there's trouble. It could be that application got corrupted. It could be maybe there was an ice storm and there was a power issue where, you know, fuel couldn't be delivered to power all of our generators, something like that. That does happen in the data center space under a severe catastrophe. But fortunately, this particular user has everything being replicated out to Las Vegas just in case that kind of event. But that, again, presents its own new challenges, right?
Yeah, indeed. And this is a situation where this slide kind of points out they're headquartered in New York, and so they have some of their applications in New York, the ones that they can that they want to host locally. But also their primary production is there in a 5200 series in Indy, and that's replicating to Vegas. What they chose to do, there are many ways to do this, and their preference simply was they had an Active Directory controller, and instead of using the replication tool to replicate it, they wanted to use the built-in. There are pros and cons to each, and our team kind of consulted on this. They wanted to use AD's built-in replication to synchronize their AD domain between New York and Indy and Vegas. The challenge here is that they like to do both kinds of tests, which is great. The kind of test they like to do is a practice test where they actually do fail completely over to the other data center, and everything works great in that fashion. The Active Directory server's waiting for them over there. The challenge is when they do their sandbox tests. Testing is very easy using the Bluelock cloud. So they do their sandbox tests, and the question is essentially, how do you do a sandbox test without that information in that sandbox, that testing QA data, leaking into your production Active Directory and starting to see servers in places that they don't belong? That could cause problems. So again, our teams worked together and came up with a solution where they're actually leveraging you'll see on the left side, that's their 5200 production data center in Indy. And on the right side, they have a production data center over there that just is big enough to house the secondary firewall that's always active and in their control, and that Active Directory server or replica out in Vegas.
So just to clarify, all this stuff here, even though it's for DR, is online all the time.
That's correct.
And that's how I can get updates, firewall policy changes, kind of all that stuff that would happen in real time, but it can maintain a sense of independence, whether that's IP addresses or names or what have you. It's essentially like a remote office.
Exactly, okay. Exactly. And this is how their firewall solution even allows pushing a singular policy to both firewalls, so they can keep that in sync without having to worry about it getting out of sync. So below, down there in the 4500, where the VMs in gray would recover, you'll notice there's a AD clone, test clone VApp. Well, normally that's empty, as the rest of the 4500. The solution we came up with leverages the runbook capability. Bluelock provides the ability to go through a procedural and tested runbook with the client when they need to test or declare. In this particular situation, when the client wants to perform a sandbox test, the first step in the runbook is to do a snap clone of their Active Directory server that's already sitting out there in Vegas, out of their production data center into that VApp that you see there in the bottom right. Once that's done and that's up and online, the VMs here can be brought online through a standard declaration, and they're all connected to the test network, and all of that is isolated from the production network, so none of that information ever goes back into production. When we're done with this, because it's a sandbox test, all of the changes to the VMs disappear, and they disappear, and the AD clone just gets deleted. So any updates that it's done, et cetera, during the testing is deleted rather than accidentally being pushed back into production.
And if it was a real test, they would basically just they would skip the snapshot of the AD and just power up those gray VMs behind the actual running firewall and Active Directory.
Absolutely. Right? Again, we leverage the ability to declare on, or to test onto a test network and declare onto a production network.
Yeah, pretty cool. I'm learning stuff about what we do. So those are two examples of in cloud and to cloud, and some of the little details that tend to crop up when you do an implementation. But those are also initial. In this particular case, we're going to talk about, I shouldn't say it's theoretical, this is very real. When someone comes online initially with recovery as a service, maybe for a handful of virtual machines, but then they realize that it is pretty effective, it does work, and they start to include more applications. In this case, it was additional business units. One business unit protected themselves fairly well, but then told the story to another business unit, and they thought they should do the same thing. And so it's actually proliferating around inside this company. They happen to be on the West Coast, so it's not a hurricane or an ice storm this time. It could be just a prolonged power outage, brownout, or hopefully not, but maybe even something like an earthquake. And they're replicating to Las Vegas, I believe. Yeah. Okay.
Yeah, they're replicating in Las Vegas to keep their keep their latency low if they need to go there. A lot of their people are on the West Coast that they need to communicate with. And like you said, that's really kind of the neat thing about the RAS solution is it's an affordable and easy to do solution, so that once they brought on their initial workload, like adopting the cloud in general, people realized, wow, that was easy and didn't nearly cost me what I'm paying on this other solution, so can I be part of that? And in being a business unit in a larger organization, that caught on like wildfire. So what was initially a sufficient bandwidth for raw replication for this business unit, we'll see faces some challenges. So raw replication feed was happening as the business unit brought on more VMs and started doing more production workload on those VMs. What we saw was the networking bandwidth, the consumption just went through the roof. So after some analysis and taking a look at this, we decided, okay, what we need to do here is to leverage the WAN compression to make sure that changes are not being shipped that don't need to be shipped across the wire. Oftentimes the trade-off in WAN compression is compute. So it was just a choice of whether or not to leverage or to take more CPU on both sides versus more bandwidth. In this case, it was a better trade-off to use a CPU to generate the WAN optimization. So WAN compression, you can see here, we're looking at a replication group here where you can see that there is a rate of change. You have your RPO. In this particular window, it was 11 seconds on this group. And then over on the right-hand side, you'll see that WAN compression is set to true. So the first pass at working with this client to address their needs as they grew was to just make that trade-off, turn on WAN compression, and bring the bandwidth back into control. And it significantly did. We saw over a 50% reduction in bandwidth used as the software was able to compensate for changed bits flipping back and forth that didn't need to be replicated every second.
And I think you could use, in addition to this, some sort of WAN optimizer like a Riverbed or other solutions that are out there.
Yeah, absolutely, and that goes to that trade-off. If you already have a solution in place and you want to leverage that, this will work just fine through that as well. So if you're taking your CPU out of an appliance you already have, or you want to put in a different appliance, however that works, absolutely, this is friendly to those.
Yeah, I think Radware, people are using Radware in our environment too.
Mm-hmm.
And then it looks like the amount of WAN traffic, which is the changes going back and forth, has a direct relation to your recovery point.
That's correct. If you think about a pipe, it can only flow so much water. So your RPO is going to be affected by your rate of change, which is how much your machines are churning, and how big your pipe is. If your pipe always has enough space to flow the water you're pouring through it, you'll never have a problem. But if there is some contention there, it's kind of like water backing up into a funnel. Not all the water is getting through to the other side. That's your RPO. So the RPO time is increasing. So if we had contention on this pipe, that wonderful RPO, here of 11 seconds would start to...
That's pretty good. I'd take an RPO of 11 seconds. So basically, if someone fires up a bunch of the latest YouTube video, that fills up the wire, it's going to
make
back up those changes in your recovery point objective. You might miss some sort of transactions.
We'll talk a little bit later in our third scenario here with this client about how we can help with that.
Okay. I know this has been a big issue, particularly with Windows, for years.
Yeah, so essentially, now we've got things back under control. So we go back to plenty of bandwidth for the replication. We have turned on compression. The story is good. What we've got here then is every night, a whole bunch of stuff kicks off. There are database dumps, there are reindexes, there are log files that get purged. There are all sorts of activity that goes on, standard nightly routines. Nothing that's really critically important to keep. It's just stuff that happens. It's ephemeral. What that drives is data writes to disk, and data writes to disk translates into bandwidth required. Like we just said, the more bandwidth you need, the more challenged you might be on your RPO. And if your RPO, if there's too much of that bandwidth, you may not just be your RPO that's impacted, but also the recovery points back in time that you have. So if you push too much change over the wire, you're not going to have a lot of recovery points back in time. So again, we took a look at this and how we can work with them to address the situation of that temporary or ephemeral changes. So, as I mentioned, the RPO can fluctuate when that bandwidth is constrained like that. I think I skipped ahead, so I'm going to stop here for just a second.
This is the initial seeding.
This is the initial seeding, and if you would go to, yeah, okay. So the other reason that bandwidth was under constraint was that as these departments said, hey, I want to participate, join in the game, they added their VMs, and there's an initial seed. So you have 10 gig, 20 gig, whatever the size of that virtual machine is, it gets pushed over that same wire. And you can see by the graph here that that impacts that recovery point, and it impacts the number of checkpoints you have back in history.
Right, because even if I've got compression turned on for all my existing replication, I've got all the I hate that word. I can't because I can't.
Temporary.
Yeah, I got that temporary data. I got my swap files marked out, so those would get replicated, all that kind of stuff. And then Bob down the hall decides that he needs to protect his data, and he turns on 20 new VMs to replicate across my same network link. All of a sudden, my RPO goes crazy.
Exactly.
But to protect his data.
Yep. So again, we're getting our teams together to optimize how we can address this solution. So the point of this is that the recovery is not just about point it and turn it on, because there are a lot of unique and different challenges for each individual customer that needs to have their needs met, and there are a lot of ways to do it. So our teams got together and worked through how do we optimize this solution. So as you alluded to, we have the ability to exclude temporary disks, swap disks from this. If there's a database dump disk or something, it can be excluded from the replication. So again, it takes those bursty chunks of data and brings them back into norm. When that database is dumped, there is no impact on the bandwidth or the rate of change. The other thing that was added is the ability to do a private pay-go type of replication circuit. So a new type of circuit that allows the client to pay for what they use as they use it for the bandwidth, and be very bursty with that type of bandwidth. It's a very flexible solution. So when that new person adds that VM that needs to be replicated and seeded, or if there is a legitimate large data write change that happens, they can burst into a space, consume it, and run with that bandwidth for as long as they need, and then they're only paying for that time that they are in that burst space.
Yeah, and that's pretty new. I think, as far as I know, TW Telecom is the only company that we know that has that kind of network capability. That's something we'll talk more about later, but that's probably one of the most interesting developments I've seen in networking in at least the last 10 years.
Yep, and it was a tool that we were able to use to be able to make this solution work for this client, to get rid of those bumps and get them back online to standard replication.
Yeah, because if you're managing the bumps, you'd still have to go and buy, pay for a 100 meg port,
right?
Even though your bumps might only be temporary, right? To get there.
If you're trickling at 5 and you need to bump up to 20, that's a challenge with today's situations. So there's 3 different challenges that we faced with those: the new VMs, the compression, and the ephemeral data that we're able to wrap up.
Okay, great. So in terms of wrapping up, Alicia, I'll hand it back over to you.
Yeah, sure. So before we move into the final question and answer, which we'll only have a couple minutes for, I'd like to launch a really quick poll. We're offering attendees on today's webinar a complimentary application recovery assessment with our professional services group. This assessment will help you determine the risk associated with unplanned downtime for 1 to 3 applications versus the costs associated with protecting them. And this would be about a 60-minute session and would also help you create your own internal template for assessing additional workloads on your own. So please go ahead and respond to the poll that's showing up on your screen so we know how to follow up with you. And while you're doing that, we'll go ahead and start diving into some of the questions that we received. The first question is, Can Bluelock support multiple types of hypervisors, or is it just VMware-based hypervisors?
In terms of multiple hypervisor support, you can replicate from your environment into a Bluelock environment regardless of the hypervisor on your side. It's just the replication software wouldn't necessarily be the type of product that we showed doing the replication today. And it would be more of a host-based replication. Probably the biggest challenge, if I look at something like EC2, would be coming from an EC2 instance into a VMware virtual machine. The VMware tools wouldn't necessarily be installed. There'd be, I would say, some additional challenges that we'd have to work through. We most often get that question related to someone who does have VMware but wants to replicate, in addition to VMware, maybe a physical machine. Mm-hmm. So we would switch to an OS-based replication software to handle the physical machine, and then put the Zerto replication software in for all the virtual machines.
Okay, great. The next question is, does Bluelock do the initial seeding online, or are there offline options, and how would that work?
That's a great question.
Yeah, so essentially the answer is both. When the online option is really not an option due to the amount of bandwidth that's available or the amount of storage. If you've got 20 terabytes or 50 terabytes in a smaller pipe, we have options to be able to work with our team, get a portable media that will allow encryption and shipping of that. We can pre-seed it on this end. So the initial bandwidth is FedEx, and then it's just deltas after that over the wire. And hopefully that's an appropriate amount.
Well, I think the other thing that's interesting is this solution actually replicates while the application is online. So traditionally, a lot of replication technology, you would do a snapshot, you'd actually have to stop the VM in order to do the replication and things like that. That would be disruptive to the production application. In this case, you could replicate up to 99% of the application while it was running. And then the deltas in terms of actually failing it over is only managing that last 1%. So even a fairly large, terabyte size, multiple terabyte size workload could be done over a period of a couple weeks.
Yes, and we've done that, and as well as if you look at our third example, the ability to add in different pieces of an application or smaller applications individually has allowed other customers to, over time, bring multiple terabytes across a limited pipe. So both options exist, and they're very flexible.
Yep.
Okay, and I know we're at the end of our time limit, but we're going to try and tackle just 2 more questions for those of you that can stay. So the next question is, if I'm going to exclude components like swap space or database dumps, what are some of the things to consider when testing the failover?
Something if you put all your temporary stuff on let's say an F drive, and then excluded it from replication, when I recover, is my F drive missing?
No, that's a really good question. It's actually designed kind of counterintuitively, but as you look at it, the simpler your recovery is, the higher chance that it's going to work. So if you imagine taking the F drive away from your computer or a swap drive away from your computer when it recovers, that would pose a challenge. Software is designed to exclude replication from it after the first replication. So that initial seed, let's say you have a 10 gig partition that is your database dump drive. That database dump drive moves over with us, and then it never replicates after that, but it's there. It's attached to the machine, and it's online. So when you do your test or your declaration, that F drive will be there, and when your machine reaches out to boot and see it, or to actually execute it, it will be able to find it and use it.
Yes, okay, that makes sense. I was just trying to imagine in my mind what would my operating system do if it tried to write a swap file to the drive where a swap file had been but hadn't really been updated, and it would just write over it.
It would just write over it.
Yep, okay.
Okay, the next question is, who does the compression? Is that the ZVM? Is it on the Zerto side or the Bluelock side?
The compression is being done, and the ZVM does the coordination. It's the VRA appliance itself that does the compression.
Okay, great.
So that's kind of distributed across multiple hosts as opposed to centralized into one place.
All right, and last question. Is there a protection group through which you guys group the applications and start the seeding at a group level, not just one-by-one VM?
Yes, exactly. The concept of the virtual protection group as part of the product is pretty key. It not only allows you to make sure that the VMs inside it are replicated in sync, but it also allows you to kind of set all the automation, set all of the networking and workflow regarding the booting. Now, when you start that up, you can choose to say this is you can organize them in terms of this is core components. Maybe that's your Active Directory or DNS or routers, firewalls, whatever they are that need to come online first. And you can make another group that's application 1, 2, 3, etc. In addition, you can add to those VPGs. So if you have started one off and you say, hey, my application is running, I've replicated this machine 1, now it's time to get machine 2 and 3 over there, they can be added after the fact and allowed to replicate. So if you have 4 machines that form a protection group, you can add them one at a time to that protection group and ramp that up slowly instead of having to take off that whole byte.
Okay. Awesome. Well, we're just a few minutes over our allotted time slot, so we'll go ahead and wrap things up. So thank you, everyone, for attending today's webinar, and thanks to our great speakers. And everyone have a